Hello everyone, my name is Cameron Evans. This will be my fluid wind tunnel project for fluid mechanics class tutorial. We're going to be using the 10 meters per second velocity. Let's begin. First, change first near geometry, design modeler. Make sure all three lines are connected. And go with 4 basic lines here. Let's delete that. So, let's delete that. Let's try this again. I like it. I'll table these. Each one will be H2 will be this line right here, and this will be this line right here. And if you did this right, they should all be connected together like one big line. And they should move together in unison. Yeah, type that one in. 1.6 into. We'll make sure we save our work. Always save your work in between processes, otherwise you'll lose a bunch of information and it's disappointing if that happens. Vertical distances. B7 would be right then. We should have this. And do some making our drawing. Make sure all these dots or lines are connected to be one big shape. Alright, let's make this look neater. Let's make this. So we can delete the middle pieces. We don't need it anymore. We should have this right here. Now we got the right dimensions. We're gonna go to concepts and create a surface from sketches. Sketch one, apply, and generate. And you should have this. Once again, save. And now, after this save, we move on to the meshing. Give me a minute, please. And share my screen again. So this here is the meshing portion of this. Let's begin. So first things first, you need to create the mesh and insert your settings. And we're gonna edit this down, make it look neater. I can make this smaller. My computer is a bit slow, so it's gonna take a minute for it to cooperate. Just give it a second here. Still meshing. Just taking this on. Well, let's do it now. See if I can name this. Right, either side of this thing. What else? Still meshing people. Okay, while we'll wait for this to finish mesh, I'm gonna show you what we'll do in the meantime. So if it was still done meshing, we would name these points right here. Of course, won't let me until this thing's still meshing. Okay. Let's create our names. Inlet. Okay, then if this doesn't clear up anytime soon, we're just gonna skip over to the next part. One moment, please. Okay, everybody, sorry about the delay, and here we're back. This is what your mesh should look like. You want to use the L triangles method. Make sure you label all your pieces, inlet, outlet, and the wall, which is basically the size of the tunnel. So for the mesh, I use the triangle method. You're going to change the element size to 1 to the negative e to the 1 e to the negative 2 power, which will make it like 0.11 millimeters almost, that's pretty much it. Then you would save it. Then you would just go down to the setup. So for the setup, it's basically 4 steps. Turn energy, change the capsule, put in the velocity value, and then of course you're gonna create your contours and save your select data plots for your actual data, which you're gonna use to make your X and Y plots in a little bit here. Almost there. Still loading. Just put my knee in the computer, as y'all can see. Okay, computer, thank you for cooperating today. So like I said before, you're gonna make sure the energy is turned on, and you're gonna want to change your viscous to K epsilon, enhance wall treatment, pressure agreements, clicked on. Click OK, and close out. Then materials, like always, we're using fluid, using air. So for the video, not here. So for this video, basically nothing changes except velocity value. So for this video, we're only doing a 10 meter per second velocity. But when you do this yourself, you're gonna have to do it for like 5, 10, 15, and 15, which is not too bad. Velocity magnitude set to 10. What I recommend is save all your work and this duplicate duplicate one project and then label them by the velocity value. And that will like do is like the setup and just change the value of the velocity. So you have to repeat the whole process again, which is a time consuming and engineers don't like wasting time. Velocity, 10 meters per second. Get to that later. And you basically want to initialize it. And then on calculation, I like to start at a high number like 300. It's not going to take that long, but you always want to start high just in case it doesn't converge. And click calculate. Let the computer do the work. Hopefully it goes fast this time. Hopefully. Actually complete. So the project, it's going to ask you to calculate the dead at the center line, which is the direct middle of the tunnel of the fluid tunnel. What I recommend is you want to create it at the create the center at the origin of the sketching, so that way it's split in half, or even. So we're gonna go to surfaces. But we will go to surfaces, click new, line rake. So for me, I did center line. I just get 0 to 4 as the total length of the line. And then for the Y, I put 0, 0 because like on literally on the x-axis, nothing's changed. And then of course you need to click some data plots from the Berger distribution, which is basically the middle of the whole fluid. Basically the middle of the whole fluid tunnel, if you can find it. Sometimes you have to eyeball, sometimes you have to guess it. Let's get to the contours. So we're gonna have 4 contours in total for each velocity. First one is the pressure. You want to click on interior surface body because we're trying to get the whole thing. Save display. Close. Go back to graphics. And it looks something like this. And if we click on the center line, it'll be right down the middle. Show you that. Save close. And then you just take a screenshot of this, snip it, and copy and paste into a Word document for your report. And you'll do the exact same thing for dynamic pressure. Save display and close. Then your total pressure right here. Total pressure right here. Save and close. Then the last one, interest by velocity magnitude, save and display and close. And then, like always, save your file. They want to click on save for future calculations. So that way it'll carry over and do your other 2 velocities. Now for the plots, so for the x and y plot, they're gonna want to plot on the center line of that data. So to give you an example, click on x and y plot, center line, save and plot, and close. It looks something like this, but for this project, he wants all three velocities on one plot. So what you would do is, so instead of 12 different plots, you're just gonna have three plots, four, no, four plots, three values on them each. So what I did was, I will click Write to File. Then what this does, it'll create data points for you, but it'll save them in a text file created by Notepad, and then I would import them, upload them into an Excel sheet. And that's how I made my Excel pie charts. It'll be more simple when I show you. I go right to File and just save it in a place where you can see it, where you'll find it easily better. But you're gonna need 8 of these. You're gonna need some for the vertical distributions as well. So for the vertical distribution, you're gonna take the line you made, which is right in the middle. Then you're gonna change the x-axis to the y-axis. Open plot and close. And just like you're gonna do with the other two, you're gonna do a write to file and save your data points in a place you'll find them easily and always label them. What I did was I saved them and I created a folder that I labeled 5, 10, 15, and 20. And label in their file called wind tunnel. That way I can find them easy. But make sure they're all in text files. If they're not in text files, you won't you won't get the right values you need. So let me so for time constraints, I'm just gonna show you what you should have. Here's what your contours should look like. 12 totals. I know it's a lot, but in the engineering world, you need them what you need. And if you're a little keynote is if you see the colors aren't really changing, that means you messed up somewhere. So you need to fix that. And here's the pressure variance for static pressure of 5 millimeters, 5 meters per second, 10 meters per second, 15 meters per second, but we just need this for the 10 meters per second with this one. So if I can, I'll quickly show you how I did it. Yeah, I say if I can because my Excel wasn't working properly with me today. All right, here we are. You go to data, text CVC file. So like I said before, save your data points in a place where you'll find them easy. Wind tunnel, and we're just gonna do the static pressure one for now, which is this right here. 10 pressure, import, load data. Yeah. And you're gonna copy and paste all this. No, copy all this first. Put every data point you need. Copy, paste, just to get the values, and then you have to convert this all to numbers. Now I gotta create our chart. Yeah. The idea is I would recommend the charts, and you're gonna want a graph like this one. You're gonna want, and of course, create your access title, legend, So your legend here would be 10 meters per second. This one will be the position in meters. This one will be static pressure. And this one just be pressure variance, like the one I showed you in my report. Now I'm going to show you what I did for the data distribution one, vertical distribution. Import the data. Since you're taking this from the y-axis, there won't be that many points to copy and paste everywhere. And paste it where it'll just be regular number files. Convert to numbers. Highlight everything. Insert. Recommended charge. And you should have something like this. And click OK. So once again, you want to label your charts. Imagine, and that's pretty much it. Now there is a bonus section of this lab, of this project, which was you're basically gonna repeat the whole thing, but include an airfoil. So I'm gonna go over that briefly with you. Your professor should provide you a Word document and some instructions on how to take a turn of word to turn the airfoil and make it into a text document where you can upload it to a workbench and you can make a drawing out of that. So give me a second. So for the airfoil, you want to make sure it's actually really small. So you will go to point. So you go to point. You would do it by instruction point. And then you would go to a coordinates file. This is where you will update your files. This is where you'll be able to update that Word document, that text file you had to turn into a to turn into a to turn into an airfoil pod. And you get this. Then after you upload your airfoil, you basically would just refresh refresh the mesh, refresh the setup. So it basically it's the same process. You're just adding in like a small shape into it. I'm not really good with words. One moment. So here's the updated template with the airfoil in it. I consider everything's the same. Oops, let's change this. So let's change this to 10 meters per second. Initialize it. So for this one, you don't really need to get the plots and everything. You just need to get two contours each. Velocity and pressure. Excuse me. Take note. Take note. Make sure your computer's up to date when you're doing this. After it's complete, now I'm just going to show you what the contours will look like. 'Cause I'm running out of time here. So you're going to zoom in just so you can get the airfoil part and observe the change in the colors. This one's for static pressure, and that's pretty much it. I hope this video was useful to you. Thank you for watching.